You are staring at a blank white screen, frantically refreshing your browser, while your website spits back a vague 500-level error code. In this moment, you face a direct operational dilemma. You have to decide whether to spend the next 3 hours digging through lines of PHP or pull out your credit card to buy an expensive server upgrade. Pick the wrong path, and the consequences compound. You either burn hours of your day repairing perfectly healthy code, or waste your budget on extra server hardware that won't bring the site back online. Server downtime is driven by strict math, not mystery. When you react to a crash with blind panic, you almost always end up paying for the wrong solution. The difference between a 500 and a 503 error looks complicated in a browser, but it traces back to a single predictable diagnostic split. A 500 error means your site is broken. Something in the software failed to execute, and the server halted the request entirely. A 503 error, or its Apache equivalent, the 508, means your server is healthy, but the queue to process incoming visitors is completely full. This comparison matrix visualizes the broken versus busy divide. On the left, we have a fatal code fault that requires debugging. On the right, we have a traffic bottleneck that requires queue management. Grasping this specific binary split is how you stop throwing money at hosting tiers and start applying exact, permanent fixes. If you reload your page 5 times across a few minutes and see a 500 internal server error every single time, traffic volume has absolutely nothing to do with it. Your server is tripping over a hard fault. You are usually looking at a corrupted .htaccess file, an incompatible PHP version, or a broken plugin update. Purchasing a higher hosting tier to fix a constant 500 error is like renting a larger garage for a car with a dead engine. You will lock your business into higher monthly hosting fees, and your website will still display the exact same white screen of death. The correct input here is the server's error log. Opening that text file will point you directly to the exact theme or plugin file causing the crash. Finding and disabling that faulty plugin costs $0 and clears the error permanently. Upgrading your server in this scenario provides zero return on investment. There is one mathematical exception to this rule. If your error log shows an out-of-memory kill isolated to an extremely heavy page, you have a resource ceiling masking as a code fault. Most tutorials tell you to fix this by pasting a memory limit snippet directly into your WP config file. But if you run heavy dynamic assets like a WooCommerce checkout, that software edit frequently fails. You save the file, and the checkout page keeps crashing. This diagram shows the two ceiling reality. The lower dotted line is your software configuration. The solid brick line is the absolute CloudLinux cap. Push your WP config limit up, but once it collides with the physical cap, the server kills the process. Because you cannot bypass your host's physical memory barrier with a software snippet, this specific memory trap mathematically requires a server tier upgrade to clear. Now look at the right side of our diagnostic map, the 503 and 508 errors. These two errors exhibit entirely different behavior. They appear exclusively during sudden traffic spikes and vanish when visitor count drops. Your code is completely safe. The server is healthy, but its internal concurrency queue is maxed out. This graphic shows your entry processes, or EP. Each simultaneous visitor takes a slot. When the funnel overflows, the server holds new requests. The error depends on architecture. Lightspeed returns a 503, Apache a 508. Both are the exact same bottleneck. Because your plugins and database are functioning normally, searching for broken syntax during a traffic spike is a total waste of time. A busy server demands one of two responses: aggressively caching your incoming traffic or paying for more concurrent worker slots. Your absolute first line of defense against a full queue is full-page caching. For standard blogs and informational websites, activating a solution like Lightspeed Cache is the required operational input. Once a page is cached, it bypasses the back-end PHP workers completely. The web server hands a static file directly to the visitor, meaning they take up absolute 0 slots in your entry process funnel. Under load, server response times plummet from over 1,000 milliseconds down to 16 or 20 milliseconds. This delivers massive return on investment. You clear the 503 errors and survive the traffic surge without spending a single dime on hardware. Caching is strictly for static content. It fails for dynamic user actions, like logging into a member portal or adding items to a cart. Let's apply these diagnostic rules directly to your operation. Consider the time-poor content blogger. You run static articles and you occasionally hit a wall of 503 errors when a post gets shared heavily. Your strict directive is to implement full page caching immediately. Refuse any hosting upgrades until your cached visitor volume itself actually exceeds your plan limits. Compare that to an e-commerce operator. Your WooCommerce cart pages are constantly processing custom pricing and inventory, resulting in queue-draining 503s or memory-based 500s. Since caching cannot process a dynamic credit card transaction, staying on a low-entry process tier ensures your cart will continue to crash under load. Upgrading to a higher EP tier or a dedicated VPS is mathematically mandatory here. The financial trade-off is obvious. The cost of a VPS upgrade is negligible compared to the real revenue lost every time a buyer hits a dead checkout button during a spike. Every server error operates on these exact laws. A 500 error means broken code, a 503 means a drained queue, and a resource limit message is just the Apache translation of a 503. This triage checklist dictates your next steps. Content blogs generating 503s map to caching. E-commerce spikes map to EP upgrades. Constant 500 errors map strictly to code fixes. Stop treating server errors as mysterious forces. Match your visible symptom to the correct server limit and only pay for the exact fix you actually need.